We have another very interesting geometry problem. So what it says that find the area of the largest rectangle, find the area of the largest rectangle that can be inscribed in an isosceles triangle. Isosceles triangles means triangles with two sides are equal, with sides 13 centimeters, 13 centimeters, and 10 centimeters. So it's like a very interesting problem. So what you're trying to do, so you have an isosceles triangle. You try to inscribe, you try to put a largest possible rectangle inside that triangle. So I mean, as you can see, this is not obvious, like, what area you can get as a maximum. So what we normally do is we use the help from calculus to solve the problem. So let's draw the situation first. So we have an isosceles triangle. So this looks like that. So what we try to do is you try to find the largest possible rectangle that you can put inside. So like that. So we have a rectangle. So we're gonna find what is the largest possible rectangle you can put there. So you can see it's not obvious. So what we normally do if you get a problem like that, we need to find those lengths. So we're gonna split this into half because the symmetry, those two triangles are congruent. So they are the same thing. So what we can do, we need some variables, and then first we know that this side is 13. So this is 13, this is 13, and the bottom is 10. So this length is 10. Um, and then you can see also this one of those small sides going to be 5. So you can see this one of them is 5. Sorry, 5, and the other one is 5 because of symmetry. Okay, now we need some variables. So what we're gonna do, we're gonna pick this width as x, so this x, and then we take the half of this as y. You will know why we do that. Just to make the algebra easier, we do that. We take half of it y. So that means this is going to be y. Now we need some relations between between x and y. To do that, what we can do, so we know the hypotenuse is 13. We know the if you look at this one small triangle, the base is 5. So we know the height of this triangle. So you can see if you write a Pythagorean identity for one of those small triangles, you can see h. If you say h is the height of the triangle, if you say this is h, so you can see from one of the triangles, h squared plus 5 squared equal 13 squared. So that's what you get from one of the triangles. And then you can see h squared equal uh, 144. So that means h is 12 because it's a positive number. You don't get plus or minus here. H equal 12. So h is 12. So that means since this side is also x, so you know this one. So this side going to be 12 minus x because h is 12. Okay. So now what we can do, we can use similar triangles to find the relation between x and y. So let's start the problem now. So we're going to say let x equal the width and the y 2y equals the length. So we take x equal the width of the rectangle, 2y equal the length of the rectangle. So now first what we're gonna do, we're gonna find a relation between x and y first. So let's do that. So using similar triangles, so you can say using similar triangles, so I'm gonna take the one like this small one and the large one. So this large one. So we can take those two triangles. So if you do those two, you can see y, if you divide y with uh, the bottom one 5, and then you can see similarly you can divide 12 minus x with 12. Those are the corresponding sides. Y to 5 equal 12 minus x to 12. So now we're going to simplify this one. We're going to solve for y. So you can see this is 5 over 12, 12 minus x. That's what you get as a relation between x and y. So now let's try the objective function. So the area, we're going to say A in this case would be x times 2y, not y, because the length is 2y. So if you plug in here, so you can see x times 2, y is 5 over 12, 12 minus x, and there are some simplification going on, so you can cancel this and with that, so you get a 6 here. So that means you're going to get 5 over 6, 5 over 6, and then if you distribute, you're going to get 12x minus x squared. So that's the function you get. And then, so your problem becomes maximize. So you can say maximize ax. I'm going to call ax now because it's a function of only x now. Earlier it was like two variable, not anymore. So it is 5 over x times 12x minus x squared. That's what you get. On what interval? You can see the smallest value of x would be 0. It's not practical, but mathematically that's a 0. The largest would be 12. So you can go up to 12. It's again not practical, but mathematically correct. Okay, so that's the problem we're trying to do. So now we know what to do. So we're going to find the derivative and find the critical point, and then use the second derivative or first derivative and show that there is a maximum at that point. So let's do that part now. So look at the derivative, which is a prime x, which is equals to, you can see 5 over 12, 5 over 6, 12 minus 2x, and then we set this equal to 0 for critical points. So it says that 2x equal 12, so that means x equals 6. So that is the only critical point. That's the only critical point you can get. Now if you look at the second derivative as before, so you can see you're going to get negative 10 over 6. Why you get negative 10? Because you're going to multiply this with that when you take the derivative. So you get negative 10 over 6, which is negative. That means there should be a maximum at the critical point. So has a maximum, So we know that. So that means we can find the maximum value. So what we do, we're going to find the corresponding y value now. So we can say when x equals 6, you can see that y equal 5 over 12, 12 minus 6. So you're going to get 5 half as the y value. So now we can write the largest area. So largest area is largest area of the rectangle is x times 2y. It's not y, is 2y. So it is, you can see 6 times 6 centimeters times, if you multiply by 2 is 5 centimeters. We'll multiply by 2 is a 5 half, so multiply by 2. So you get 30 centimeters squared as the largest area. The dimension that makes the area largest is, so the dimension that makes the area largest is 6 centimeters times, or you actually sometimes we write dimension, we write times 5 centimeters. So when you have a rectangle with that has the largest possible area. So that's how we solve the problem.